Hey guys, again, this is a flipped classroom, so we do all our notes by video at home. So this is our first video. Sorry, sometimes it jumps around. So we're looking at our first target, and the first thing we always want to look at is our master learning objective. I can solve problems involving ratios by using the cross product property to solve proportions. Lots of words there. So we're solving problems. We're going to use ratios, so we want to know what those are. We're going to use the cross product property, so we want to know what that is. And then we're going to solve proportions, so we'll want to know what that is. So the first thing we're going to look at is what is a ratio. A ratio is a comparison of two quantities. So again, it's a way to compare the amount of two things. There are three ways to write ratios. You can say A to B, colon B. This also says A to B. Or A to B that way. Division also represents a ratio. So let's look at example 1. In Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-to-teacher ratio at his school? So we're going to want to do students to teachers, because that's what it says here, student-to-teacher ratio. And we have 2,650 students. And we have 190 teachers. So I'm going to pull up my calculator, and I have 2,650 students and 190 teachers. And it gives me this, so we could leave it as this, 265 to 19. But it wants it approximately, right? And usually we want like that, want this to one teacher or whatever. So we're going to get the decimal. To approximate that decimal again, it's this control button and then enter. Okay, it gives you the decimal instead of the fraction. So that's approximately 14. I'm rounding. 14 is technically over 1. So now we can go back and write our ratio as a 14 to 1 student-to-teacher ratio. Okay? Approximately. So you'll see that, like, if you're ever looking at colleges, you'll see that a lot. They'll tell you about approximately how many professors or for every student, or how many students for every one professor. Alright, the next thing we're going to look at is an extended ratio. An extended is just used to compare three or more quantities. So we go back to like a school example. I could say, oh, I want to know students to teachers, but then like to administrators or like principals, you know what I mean? So you could have you could add another aspect to it. In a lot of our videos, in our notes, I have problems that are probably more difficult or like a challenge or an extension of what we're doing, and they're always in an extra video. Example 2 is our first example of that. So right now we're going to skip this example. If when you do your activity you're getting to problems that are more difficult, the challenging problems, it's good to go back and watch those videos. But it's maybe not necessary for like everything we do. Okay? So we're going to skip example 2 for right now. We will come back to it. Next we have a proportion. A proportion is an equation stating that two ratios are equal. So for example, I could have A to B is equal to C to D. In these equations, A and D are what we call our extremes. C and B are what we call means. Okay. So extremes are like, if you kind of think of it reading like down and then down, these are on the outside and these are on the inside. Our last vocab we're going to look at right now is our cross product property. Our cross product property is the product of the extremes equals the product of the means. Okay? One thing to remember is that product is multiplication. Alright, so again, using that same example, if I have A over B equal to C over D, I'm going to find the product of my extremes. Again, my extremes are here. It's in this diagonal. So I have A times D equals the product of the means. Oh, that didn't write correctly. Didn't even notice. Means. So I'm multiplying across this diagonal. B times C. And that's all that cross product property tells us. Sometimes we call it the lovely butterfly method because of the beautiful butterfly that it makes. Alright, let's look at our next. Go ahead, turn the page. Alright, we are now looking at example 3. We have 4 questions here with solving proportions. Okay, using that cross product property. Multiply the extremes, multiply the means. So looking at A, x over 4 equals 11 over negative 6. I'm going to multiply my extremes, x times negative 6, and then multiply my means, 4 times 11. X times negative 6, again, anytime you multiply a variable just by a number, that number just becomes its coefficient. So it's negative 6x equals 4 times 11 is 44. Now I'm solving for x, and when I'm solving for x, right, I need to get this x by itself. It has this negative 6 being multiplied with it, so I'm going to divide by negative 6. They cancel here. I'm left with just that x. 44 divided by negative 6. You can always use your calculator again. And I personally like things as an improper fraction, right? Not a mixed number, not decimal. For the most part, we're going to keep things as improper fractions. Okay? Or a fraction in general. If you have a different calculator and you don't know how to put things from like a decimal to a fraction, make sure you ask on like this first day so that you then understand how to do that. So we have x equals right, looking at B, same type of thing. I'm going to first multiply my extremes. However, here I have x plus 3 over 2 equals 4x over 5. The one thing we have to be careful is we have to put our parentheses around anything that has an addition or subtraction sign. So parentheses, can't spell, when addition or subtraction. And we'll see why in a second. So now that I have those parentheses, I can multiply here. So I have x plus 3 times 5. So multiply my extremes and then multiply my means. When I multiply x plus 3 times 5, I want to make sure I have parentheses, because without it, you might just multiply the 3 and the 5. However, with the parentheses, it reminds us that I have to multiply both of those things. So use that distributive property. So now I have 5x plus 15. And then 2 times 4x is 8x. Now I'm solving this, okay? With solving, remember we want to get all of our x's together. I have x's here and x's here, so I need to get rid of one of them. It doesn't really matter which one you get rid of. I tend to get rid of the smaller one, or in this case, the one with a constant, right? It's less steps. But if you get rid of the 8x, it will still eventually work out the same way, okay? So I'm going to get rid of this 5x. It's positive, so I'm going to subtract that whole term. This cancels. So I'm left with just 15. 8x minus 5x is 3x. Now I'm going to divide by 3. Right? So again, that's being multiplied. So these cancel. 15 over 3 is 5. Okay, here I'm going to ask you to pause the video. I guess not right away. And you're going to pause the video and work on C. You're going to try it on your own. So I'm going to wait a few seconds. Pause it, try C, and then start the video again, and you'll see if you're correct. This allows you to try it first and see if you have any questions before coming into class. All right, at this time, you should have paused your video, and you should have an answer for C. So let's go ahead and do C. I see subtraction signs and addition signs, so we have our parentheses around those. And then I'm multiplying my extremes. And I'm multiplying my means. My next step is to actually multiply, so I have to do my distributive property. So you should have 7z plus 28 equals 9z minus 9. All right, now here, again, I have z's on both sides, so I need to get rid of one. I'm going to choose to get rid of my 7z just because it's a smaller number. Again, it does not matter. Those cancel. I'm left with 28. 9z minus 7z is 2z minus 9. Trying to get z by itself, so I have to get rid of this minus 9. So I'm going to add 9. 28 plus 9 is 37. 2z. These 9s are gone. Now again, getting z by itself, I'm dividing by 2. cancel. 37 halves, I'm not going to type it in the calculator, but if you do, you get 37 halves equals Z. A little arrow. Ran out of some space. Alright, and that's it for that one. Alright, looking at D. D is going to go in our extra video. It involves factoring, so it's a little more challenging. So if you'd like to look at that one, feel free. But go ahead, go down to example 4. Fernando conducted a survey of 50 students driving to school and found that 28 owned cars. If 755 students drive to a school, predict the total number of students who own cars. So what are we comparing here? I'm comparing students who drive, right, the driving, to students who own. Those are the two things I'm comparing, so that's how I'm going to set up my proportions. So, in the first sentence, Fernando conducted a survey of 50 students driving. That's 50 that are driving. 28 owned. Alright, so I put driving over owned. Now it says 755 students drive to school. So again, driving is on top. Predict who owned. So that's what I'm solving for. Now I'm doing the same thing we did in our problems. 50 times x. I don't know why I changed to green. That's okay. 28 times 7, 55. When I multiply those out, I get 50x equals 28 times 755 is 2,100. 21,140. Now I'm getting x by itself, so I'm going to divide by 50. If I divide that, I do get a fraction. However, now, this is a real world problem. I don't know what 2,114 fifths of a person means, so I am going to get it as a decimal. What I just did is hit Control and then Enter. You see that little squiggle sign? That means approximate, and so it does get it as a decimal. So now we have 422.8, but again, I don't want 0.8 of a person, so that's 423 students. And that is it. I'll see you guys tomorrow.